Welcome back to another video. Today we're gonna prove that if a is an odd integer, then a divide a square minus 1. Let's start to prove this. Again, if you let a to be an odd integer, so we know that when a is odd, it typically have an integer k such that a equal to 2k plus 1. Now let's calculate a squared minus 1, which is 2k plus 1 squared minus 1, which is 4k squared plus 4k plus 1 minus 1, which is 4k squared plus 4k. And we are unable to factorize k. Okay, so what can we do with this? We need to increase the number in the front of k. Okay, so I want to take a look at the number that divide a square minus 1, which is 8. So I have to consider the number a and 8. Okay, number a and 8. So let's prove this. Okay, prove this, and we let a be an odd integer. Okay, let a be an odd integer, and then we have to consider odd integer a and 8. Okay, then by the division algorithm, what do we have? Okay, so this is q, which is an integer, such that a equal to aq plus r, where r is greater than or equal to 0, less than absolute value of 8. Okay, that's what we have. But our a is an odd integer, so we are unable to list all the number r greater than or equal to 0, less than 8. Okay, here's what we have. Since a is an odd integer, okay, since a is an odd integer, what do we have? We're gonna have a equal to aq plus 1. It can be aq plus 1, okay, and a equal to aq plus 3, or a equal to aq plus 5, or a equal to aq plus 7. That's it. So there will be 4 cases. Okay, let's deal with these 4 cases. So we start with the first case, the case where a equal to aq plus 1. Let's try to write a square minus 1. So what do we have? A square minus 1 turns out to be aq plus 1 square minus 1, which is 64q square plus 16q plus 1 minus 1, which is 64q square plus 16q, and factorize number 8. So it turns out to be 8 times aq square plus 2q. We can factorize number 8, so that means that a is a factor of a square minus 1. So we have a divide a square minus 1 in this case. Now let's go to another case, the case where a equal to aq plus 3. So what happened in this case? For this case, we're gonna have a square minus 1 equal to aq plus 3 square minus 1. Then what do we have? We're gonna have 64q square and 48q. and 9 minus 1. Then it turns out to be 64q squared plus 48q plus 8, and factorizing by 8, so we're gonna have 8 times 8q squared plus 6q plus 1. And this is an integer multiplying number 8. That means that 8 is a factor of a squared minus 1. Okay, so 8 divide a squared minus 1. Okay, let's go to another case. Case A equal to AQ plus 5. What do we have? Okay, what do we have? We're going to have a squared minus 1, which is AQ plus 5 squared minus 1. So what is AQ plus 5 squared? We're going to have 64Q squared plus 80Q plus 25 minus 1. Then it turns out to be 64Q squared plus 80Q plus 24. Then it turns out to be 8 times AQ squared plus 10Q plus 3. So 8 is a factor of a squared minus 1 again. Okay, great. So 8 divide a squared minus 1. And the last case, what is this case? A equal to AQ plus 7. Okay. So what happened in this case? So we're going to have a squared minus 1 equal to AQ plus 7 squared minus 1, which is 64Q squared plus, okay, give me a second. 16 times 7 is 122Q plus 49 minus 1, which is 64Q squared plus 112Q plus 48. And factorizing with 8, so that we're going to have 8 times AQ squared plus. Okay, what next? Factorize 112. So we're going to have, okay, let me start with number 1. Is 14. Is 14Q plus 6. Okay, so 8 times 14 is 80 plus 32, so it's going to be 112. Therefore, as we can see, we have 8 as a factor of a squared minus 1. That means that a divide a squared minus 1. Okay, so this is what we have right here. Therefore, we have shown that if a is an odd integer, okay, then a divide a squared minus 1. So that's what we have right here. Okay, so we have proved this example already. So that's it for today, and see you in the next video.